Why is orbital eccentricity key to successful insertion? Imagine trying to park a car perfectly in a tight space. You need just the right angle and speed to fit smoothly. In space, spacecraft face a similar challenge when entering an orbit. The shape of that orbit, which is described by something called orbital eccentricity, plays a huge role in how well the spacecraft can settle into its new path. Orbital eccentricity measures how much an orbit deviates from a perfect circle. If the orbit is a perfect circle, the eccentricity is 0. If it's more elongated, the eccentricity gets closer to 1. This shape affects how close the spacecraft gets to the planet or body it's orbiting and how far it travels away. When a spacecraft is launched, it's usually traveling fast enough to escape Earth's atmosphere and reach space. But to stay in a stable orbit, the spacecraft needs to be placed at just the right altitude and velocity. That's where eccentricity comes in. By adjusting the eccentricity during the insertion process, engineers can control the orbit's shape and size. For example, if the goal is to observe Earth with consistent imaging, a low eccentricity orbit, close to a circle, is best. This keeps the satellite at a steady altitude, making data collection more reliable. On the other hand, some missions need the satellite to move closer and farther from the planet. These use more elongated orbits with higher eccentricity. This allows the satellite to cover different regions or perform specific scientific tasks. Controlling eccentricity also helps with timing. When a spacecraft is at the closest point to Earth, called periapsis, it moves faster. When it's at the farthest point, called apoapsis, it moves slower. Knowing this, mission planners can decide when to fire thrusters to adjust the orbit. This precise timing ensures the spacecraft reaches the right position and speed for its mission. Adjusting eccentricity during insertion also affects fuel use. A well-planned orbit with the right eccentricity minimizes the amount of fuel needed for corrections later. This saves money and extends the satellite's operational life. In essence, eccentricity shapes the orbit's form and energy. It influences how fast the spacecraft moves, how high or low it is, and how it gets to where it needs to be. By mastering eccentricity, engineers can make sure the satellite is in the perfect orbit to meet its mission goals. This control is a key part of successful orbital insertion and long-term satellite operation.